Welcome to Brain Vision.
So here in this problem we are given that oxygen is compressed in a piston cylinder device and its initial condition we are given as the specific volume V1, it is 0.8 meter cube over kg and its initial temperature is 25 degrees Celsius, and the final specific volume is 0.1 meter cube over kg and the final temperature we are given as 287 degrees Celsius, and we have to calculate the entropy change of the oxygen during the process. Now before proceeding with the answer, we should know some input data, that is, the first one is the gas constant R and its value for oxygen is 0.2598 kilojoule over kg Kelvin, and we have obtained this value from the table A1 as per given in the book. And the molar mass of oxygen, we know it is 32 kg over kilomole. Now the average temperature of if we consider the average temperature to calculate the constant constant volume specific heat, so T average, if we consider, it is 298 Kelvin, because if you convert this thing 25 degrees Celsius into Kelvin, we'll get 298 Kelvin, plus this thing will get 560 Kelvin. So divide by 2 and its average temperature comes out to be as 429 Kelvin. And the specific heat of oxygen at constant volume, according to this average temperature, CV average, it will be 0.690 kilojoule over kg Kelvin. Now we can use the direct formula of the entropy change for the given process, that is delta S will be CV average natural log T2 divided by T1 plus R natural log V2 divided by V1. So we have all the values, we can plug it in this formula to calculate the entropy change. So CV we have 0.690 kilojoule over kg Kelvin times natural log T2 divided by T1. So T2 we have 287 degrees Celsius, but if you convert this thing into Kelvin, we'll get 560 Kelvin, divide by 298 Kelvin, plus R we have 0.2599, it is kilojoule over kg Kelvin, times natural log V2 divided by V1. So V2 we have, let me rub this, CV we can write it here, CV it is 0.690 kilojoule over kg Kelvin. So ln V2 divided by V1. So V2 we have 0.1 meter cube over kg, divided by V1 we have 0.8 meter cube over kg. So we're going to simplify this and we'll get the value of delta S as nearly negative 0.105 kilojoule over kg Kelvin. So this is the entropy change for the given process. So I hope you got the problem. Thank you.